Hello and welcome back to our channel. Today we'll be doing question 1 from the 2013 Step Paper 1. This question I have called Quadratics in Quadratics. Question 1, Part 1. Use the substitution root x equals y, where y is greater than or equal to 0, to find the real root of the equation x plus 3 root x minus 1/2 equals 0. Part 2. Find all real roots of the following equations. A. X plus 10 of root x plus 2 minus 22 equals 0. Part B. X squared minus 4x plus the square root of 2x squared minus 8x minus 3, all minus 9 equals 0. As this question is slightly short, I've also created a special bonus question which I've hidden a bit further down. Pause the video to have a think, and once you're ready, restart to see the answer. Let's get started. Part 1. If y equals root x, then x equals y squared, where y is greater than or equal to 0. Therefore, substituting for this back into the equation, we have y squared plus 3y minus 1/2 equals 0. Multiplying everything by 2, we have 2y squared plus 6y minus 1 equals 0. We therefore have y equals negative 6 plus root 42 over 4 by the quadratic equation. Negative 6 minus root 42 over 4 is not allowed because that would be less than 0. We therefore have x equals y squared equals 42 plus 36 minus 12 root 42 over 16, which is equivalent to 3 minus 3/4 root 42. And that's the answer to part 1. Now let's move on to part 2. Part A. Let y equals x plus 2, where y is greater than or equal to 0. We then have y squared equals x plus 2, and x is therefore y squared minus 2. Y squared minus 2 plus 10y minus 22 equals 0, and therefore y squared plus 10y minus 24 equals 0. Factorising, we have y plus 12 multiplied by y minus 2 is equal to 0, and therefore y equals 2. Y cannot be negative 12 because that would make y less than 0. From there, substituting back in, we have x equals 2. Part B. We have y equals the square root of 2x squared minus 8x minus 3, where y is greater than or equal to 0. From here, we have y squared equals 2x squared minus 8x minus 3. X squared minus 4x minus 9 is equivalent to half of y squared minus 15 over 2. We therefore have half of y squared minus 15 over 2 plus y equals 0. Y squared plus 2y minus 15 equals 0, and therefore y plus 5 multiplied by y minus 3 equals 0. Y therefore equals 3, and y cannot equal negative 5 because negative 5 is less than 0. From here, we have 2x squared minus 8x minus 3 equals y squared, which is 9. We therefore have x squared minus 4x minus 6 equals 0, and so x equals 4 plus or minus root 40 over 2. Notice that x doesn't have any limits on whether or not it can be greater or less than 0. We therefore have x equals 2 plus or minus root 10. Now let's move on to the bonus question. Solve x squared minus 7x plus 11 all to the x squared minus 13x plus 42 equals 1. Pause the video to have a think, and once you're ready, restart to see if you're right. It's important to notice that if we set a to the b equals 1, then either a equals 1, or b equals 0 and a doesn't equal 0, or a equals negative 1 and b is even. Now, if b equals 0, then a cannot be 0, because 0 to the 0 is undefined in maths. For more, you can check this out on Wikipedia, which has a very good article on this. From here, we just need to set x squared minus 7x plus 11 equals 0, and x squared minus 13x plus 42 equals 0, and x squared minus 7x plus 11 equals negative 1. If we solve these, we have x equals 2 or 5, or x equals 6 or 7, or x equals 3 or 4. Now, checking x equals 6 or 7, we see that both of these values are safe because they do not make a 0. Checking x equals 3 or 4, both values give b to be even, and therefore both of these values are also very safe. Therefore, in total, we have x equals 2, 3, 4, 5, 6, and 7. And that's the answer. If you liked our solution, please like and subscribe, and we'll see you next time for more fun maths problems. Thanks for watching, and goodbye.